Hi, this is Doris Ann Mertz. Welcome to Part 8 of ACT Math Prep. We're going to talk about various subjects today, including scientific notation. We're going to cover matrices, vectors, permutations, combinations, sequences, not necessarily in that order, but that's some of the things we're going to touch on today. These are things that might or might not show up on the ACT. So scientific notation is just shorthand for writing numbers, and you're using the power of 10. It's really quite simple, so don't be scared of it. You just, your main number is going to be a number from 1 to 10, and then you're going to multiply it by a power of 10. And how you determine what that number is if you have 1.2 times 10 to the 12th power, all you do is move the decimal point 10 places to the right. So you would add 9 zeros to this, and that would be your answer. So numbers that have high powers of 10 are going to be large, and numbers that have high negative powers of 10 are going to be smaller and smaller, infinitely smaller. So 3.8 times 10 to the negative fifth, you simply take your decimal here and move it 5 places to the left. So you would put 4 zeros in front of your 3, and that would be your answer. So it's really quite simple. So just remember how to do that. Complex numbers, they are imaginary numbers, and they're involved when you end up with negative signs under your radical sign. They made up this imaginary number that I squared is equal to -1. So when you end up with a negative number, you can just take the negative out and put an I square in there and keep working the problem. So most of the questions that you have on the ACT, you just have to recognize that I square equals -1. Maybe you've worked something out and there's an I square in your number, and you just change that to a -1 and continue working it out. Another thing that you might be tested on is recognizing that there's a pattern in these imaginary numbers. So let's look at the pattern. I to the 0, just like I to any number raised to the 0 power, equals 1. I raised to the first power, like any number raised to the first power, equals itself. So an I to the I squared, that's the definition of an imaginary number. It equals -1. I to the third power equals -I. And then the pattern repeats itself. So it goes 1I, -1, -I. So it starts at 0, goes to 3, starts again at 4. So the way this would be tested is you may have a large exponent here. It may be I to the 27th power, and you just have to recognize that you need to divide that by 4, and what matters is the remainder. So I to the 27th power has a remainder of 3, and you would know that that would be I to the third power equals -I. So that's how that may be tested. All right, let's look at one. Given a positive integer n such that I to the n equals 1, which of the following statements about n must be true? When n is divided by 4, the remainder is 0, 1, 2, or 3. So when did I raised to what power equaled 1? Remember our pattern went 1i, -1, -I. Remember that pattern? 1i, -1, -I, and it started at 0. So if you look at that pattern, it's when there is no remainder when you divide by 4. So it's when the remainder is 0. All right, in the complex numbers where I squared equals -1, what is 1 over 1 plus I times 1 minus I over 1 minus I? So if you'll remember your difference of squares, you can multiply these two on the bottom quickly and know you're going to get 1 squared minus I squared, which is 1 minus I squared, which I squared we know is -1. So 1 minus -1, we're going to have 1 plus 1 in the bottom. We're going to have 2, and we're going to have 1 minus I on the top. So it's going to be 1 minus I over 2. So J. All right, now we're going to talk about permutations and combinations. A permutation is just a kind of a combination of things when the order does matter. So P for position matters. That's how I remember it. Permutations, P, position matters. Whereas a combination, the order does not matter. So there's several scenarios here. Sometimes repetition is allowed, such as in a license plate. When repetition is allowed, you would just have your N is the number of things you choose from, like if you had 26 letters in the alphabet, And R is the number you choose. Like if you were choosing 4 of those letters, you would just have 26 raised to the 4th power. That's how many choices, how many permutations there would be. So that's when repetition is allowed, and that's the simplest form. When repetition is not allowed, you have to use a factorial. Factorial is identified by an exclamation mark. This is problems where you might have seating charts or officers of clubs, because once one of the 20 students has been president, they can't be vice president. So now you only have 19 students to choose from for the next office. So it's those kind of problems. A factorial is just, this is what 3 factorial means. It means 3 times 2 times 1. So that's what any number factorial, you just keep going down by 1 each time. Permutations may be written several ways. They may be written P and then N comma R in the parentheses, or NPR like that, or NPR like this. And the formula for a permutation is N factorial over N minus R factorial. But the easiest way to solve a permutation is to use your calculator. And the way you would do that is you would put N in, whatever your N is, the number of things you're choosing from. And then you'll either have a probability key, a PRB key, or you may have to use a math key to get to the probability key. And when you get there, there'll be an NPR option and an NCR option. One's for permutation, one's for combination. So when position matters, when order matters, choose NPR. So you put in the number you're doing, put in NPR, and then put in how many you're choosing, and then press enter, and that would give you the answer. Combinations, this is the formula for a combination. So let's look. A permutation is N factorial over N minus R factorial. A combination is N factorial over N minus R factorial times R factorial. A combination, there's going to be fewer combinations than there are permutations. So let's look at why that is. If you're choosing numbers 1, 2, 3, and you are supposed to choose 3 of them, and the order doesn't matter, there's only one choice, one answer to that combination. But if the order does matter, you have to figure out all the different ways that can be arranged. So if you put that into your calculator, you would see that it shows up the same. So on a calculator, you would do the same process as you did for NPR, except you would choose NCR, and this is when order doesn't matter. And so you do the N, then you'd get to the NCR, and then you press the R and press enter. So if you put in 3 and then NPR and then 3, you'd get an answer of 6. If you put in 3 and then got down to your NCR and put in 3, you'd get an answer of 1. And like I say, you get to this different ways on different calculators, but it's either going to be that there'll be a PRB key on your calculator or maybe a math key on your calculator. But anyways, get familiar with your calculator, find out how to get to those options where you have NPR and NCR, because that will help you on these problems. All right, here's an example. License plates on cars in a certain state consist of 3 letters taken from the 26 letters, followed by 3 digits taken from the 10 digits. Which of the following expressions gives the number of distinct license plates that are possible, given that repetition of both letters and digits is allowed? Repetition is allowed, so all we're doing is raising N to the R power. So we're raising 26 letters, and we're choosing 3 of those, so we're raising that to the 3rd power. We got 10 digits, we're choosing 3 of those, so we're raising 10 to the 3rd power. So we're going to have 26 cubed times 10 cubed, which is not one of our options, but it's the same thing as 10 cubed times 26 cubed. So your answer is F. All right, which of the following expressions gives the number of permutations, remember position matters, remember our formula, of 15 objects taken 5 at a time? All right, we're going to have 15 factorial in the top, and then in the bottom we're going to have 15 minus 5 factorial, and that is D. If you'll remember, permutations have more answers than combinations. This is the formula for a combination. It has fewer. It has a larger number in the denominator, which would result in fewer options, a smaller number for your answer. So this is the permutation formula. This is the combination formula. All right, let's talk about sequences. We're mostly going to focus on arithmetic sequences. And that is when you're determining like the the nth term in a sequence, and you're raising it by a certain amount, adding a certain amount each time. So like this would be if you were calling and you were adding 5 different calls each day, and how many would you have on the 10th day or whatever. So the basic formula is the nth term. Like if you wanted to know how many you were calling on the 10th day, if you were adding 2 extra calls each day, you'd take your first term plus the n minus 1. So if we were talking about the 10th day, that would be 10 minus 1 times your difference. So if you were adding 2 calls a day, that would be your difference. Now, sometimes they want to know the sum, like how many calls did you make in all 10 days? So the sum, you have to find the nth term first. And so then you would find the nth term and then add it to the first term plus the nth term, and then you would multiply that by n divided by 2. Geometric sequences are not don't show up as often on the ACT, but it's just your first term times r raised to the n minus 1 power, okay? The r is the difference in the ratio. That's how much you're multiplying each time by. All right, the third and fourth terms of an arithmetic sequence are 13 and 18 respectively. What is the 50th term of the sequence? So 50 is our n. What is our A1, our first term? We got to figure that out. So the third and fourth terms we know are 13 and 18. There's a difference of 5 between those. So we know 5 is our D, our difference. Our first term, we're going to go back 5 to get to 8, and then we're going to go back 5 more to get to 3. So we're going to say a to the 50th power equals 3 plus 50 minus 1 times 5, which was our difference each time. So we work that out and we get 248a. All right, here's one where we got to tell the sum. On his first day as a telemarketer, Marshall made 24 calls. His goal was to make 5 more calls on each successive day than he had made the day before. If Marshall met but did not exceed his goal, how many calls had he made in all after spending exactly 20 days making calls? So we're going to have to figure out the 20th day, how many first. So let's do that. We're going to do a to the n, a to the 20th is equal to our first call, 24, plus n minus 1. We're talking about the 20th day, minus 1 is 19, times our difference, which was 5. So a to the 20 equals 119. That's our 20th term. Now we have to add that 20th term to the first term. So 24 plus 119 is 143, and we multiply that by the nth term divided by, by the n divided by 2. So we had 20 days, so 20 divided by 2 is 10, and our answer is 1,430. All right, matrices have been showing up on the ACT lately. You may have to know how to add and how to multiply matrices. To add 2 matrices, you have to have the same number of rows and columns in both matrices. And this is how you add them. If you look down here, to add this matrix to this matrix, you add the 1 to the 2 and put that here. Then you add the 5 to the -1, put it here. So you just put things in the same position when you're adding matrices together. And you have to have the same number of rows and columns. All right, when you're multiplying matrices, the number of columns of the first matrix must equal the number of rows of the second matrix. And then the resulting answer will have the number of rows of the first and the number of columns of the second. I'm sure that didn't make a lot of sense, but if you wrote it down, like if you have, this is a 2 by 3 matrix, and if you wrote that down here and you have a 3 by 2 matrix here, then you would have, these two have to match these two on the inside. So you have a 3 here and a 3 here, so they do match. And your answer would be, you had a 2 here and you had a 2 here, so your answer would be a 2 by 2. So this is what your answer will be, how many rows and how many columns it'll be. And these must match or you can't even do it. So this is how you do it. If you're multiplying this matrix by this matrix, you have to multiply the 1 by the 7 plus the 2 by the 9 plus the 3 by the 11, and all of that goes into this first little spot here. So it's a little different than adding matrices. So you need to learn how to multiply these, and you need to learn when you're allowed to multiply them. And it's not always like just because you can multiply A by B, you can't necessarily multiply B by A. So this was a 2 by 3, and this was a 3 by 2. So you can multiply A by B, but you couldn't go 3 by 2 times, well, I guess, I mean, 3 by 2 by 2 by 3. I guess you can in this, but sometimes it's not necessarily always true. So let's look at some examples here. Which of the following 4 matrices are given below? Which of the following matrix products is undefined? So Wx, we got a 2 by 2 by 2 by 2. That works. Wy, 2 by 2 by 2 by 3. That works because the 2 and the 2 work. 1 by z, we got a 2 by 3 and a 3 by 2. So those inner numbers, they're both 3, so that works. XW, so we got 2 by 2 by 2 by 2. That works. XZ, we got 2 by 2 by 3 by 2. So we got 2 by 2 by 3 by 2. That's not going to work because there's 2 columns in the first one and 3 rows in the second one, and you can't do that. Now, on the other hand, if you would have said 3 by 2, if you'd have said z times x, you could do that. X times z you cannot, but z times x you could because it's a 3 by 2 by 2 by 2. So then the inner numbers would match. And I don't know if that makes sense or not, but just practice some problems on that, or look it up on the internet if that didn't make sense to you, until you understand that the columns of the first has to match the rows of the second for you to be able to multiply it. All right, another way that you might be tested on matrices is you have to determine the determinant, and that is a pretty easy question, even though it may end up at the end of the test, like this is number 57, but it always gives you that formula right in a note in the question. Determine a matrix ABCD equals AD minus BC. So they give you that, and you just have to plug in the other things. So here's the question. For what positive real value of K, if any, is the determinant of the matrix K4, 3K equal to K? So we're going to write that out. We're going to put AD, that'd be K times K, that's K squared, minus BC, which is 3 times 4, so minus 12, K squared minus 12 equals K. And if we have K squared minus 12 equals K, we want to get that K over on the left and set it equal to 0. So K squared minus K minus 12 equals 0. Then we're just going to do reverse FOIL to get these factors. So we're going to have K minus 4 times K plus 3, because 4 and 3 multiplied together make 12, and we would have one negative and one positive. We need the larger one to be negative. So K minus 4 times K plus 3 equals 0, and then we solve for K and get 4 and negative 3. Now we only have one answer up there, but that's because it said what positive real value of K, and there was only one answer that was a positive value, and that's K equals 4, so the answer is B. All right, let's talk a little bit about vectors. They've shown up recently on ACT tests, and they may be tested in several different ways. A vector has a magnitude, that's how long it is, that's how long the vector is, and a direction, and that's just what direction it goes in. You can add them together. The easiest way is by joining the tail of one to the head of the other. So that's the way we're going to do it when we have to add a vector. And to subtract it, you would just make the second vector go the opposite direction from what it's going in the initial picture. You can also add them together by adding the X parts and the Y parts, or the components, and we'll do a little example of that. And vectors are sometimes written in I and J unit notation, and you can add the I and J components. I is simply the difference in the X values, and J is the difference in the Y values. Here's an example of how you would add them. If you had 8I plus 4J plus 12I minus 3J, you would add these components, the 8 and the 12, to get 20I. And then you would add the Y components, the plus 4 and the minus 3, and you'd get plus 1J. All right, let's do this one. It says vectors AB and CD are shown in the standard coordinate plane below. One of the following is the unit vector notation of the vector AB plus CD. Which one? So we're going to do that head to tail addition. We're going to put the head of this one at the tail of this one. So we're going to put C right where B is, and B is at 3. B is at 3, 4, and we're going to put C there at 3, 4, and then we're going to go up 1, 2, 3, 4, 5. So C is going to end up at 3, 9. 4 plus 5 is 9. So we're going to end up at 3, 9. We started out, A was at -6, -2, and now we're at 3, 9. So to get this IJ notation, we just take our difference in our X values and our difference in our Y values. So we went from -6 to 3, so that is an addition of 9, so it'd be 9I. And we went from -2 to 9, so that's a difference of 11. So it's going to be 9I plus 11J. Here's a problem where you might see vectors in component form. This, once again, is one of your harder problems. It's up in the 50s. The component forms of vectors u and v are given by u equals vector 5, 3, and v equals 2, -7. Given that 2u plus -3v plus w equals 0, what is the component form of w? So we're just gonna plug these things in and distribute them. So we're gonna put 2 times this 5, 3 plus -3 times 2, -7 plus w equals 0. So we're gonna distribute the 2 and we're gonna get 10, 6. We're gonna distribute that -3 and we're gonna get -6, 21 plus w equals 0. So if we add those together, 10 and -6 is 4. 6 and 21 is 27. There's an answer up there that says 4 and 27, but that's just the answer on the way to the answer. Don't fall for that trick. The ACT tries to do that. You got to continue because we're wanting W. 427 plus W equals 0. So W is going to equal to -4, -27. So the answer is G. All right, that's all I have for now. There may be other things that show up on the ACT test that we didn't go over, but I've tried to show you the most common things you'll find on the ACT test. If you aren't understanding the trigonometry or the matrices or the vectors, don't panic. Just really focus on getting the pre-algebra, algebra, and geometry down pat, because that's what the bulk of the test is. And all the questions count the same. Every answer gives you equal amount of points. I just wanted to remind you to not, even if you know how to do a problem, but it's going to take a while to do, like those sequences, mark that and save it for last and come back to it later, because you might could get 2 or 3 easier answers in that amount of time, and they all count the same. So don't waste your time. Don't get sucked in wasting your time on one problem. Mark it and come back later. And remember to not panic when you don't know how to do something. Just if you have no clue, just guess your letter of the day. If you can figure out a little bit of it and eliminate some choices, do that. So good luck. If you have any questions, if you just want to take a picture of a problem you don't understand how to do and send it to me, my email is here, cuslib@gwtc.net. You can call me on the phone, whatever. I'm here to help you. I work at the library. You can drop by and see me sometime, call and make an appointment, whatever. And but yeah, if you just send me a picture, I'd be glad to walk you through how to do it. So thank you for watching. Good luck on your math test, and I know you're going to do great.